Okay, we're going to talk about what I call, or what's called in math, piecewise functions. And let me just back up here. Wasting valuable time. Okay, here we go. Should have been ready. Piecewise functions. Okay, that's where we have a different function for a different part of the domain. Okay, we're going to have, here's an example. F of x will be basically y equals f, like y equals f, or f of x equals x, if x is greater than or equal to 0. So for this domain, this is our function, basically y equals x, or f of x equals x, okay? For this domain. And then if x is less than 0, for this part of our domain, we have a different function, negative x, okay? So remember f of x, the function of x, that's an output, that's just kind of like y, our output. Y equals x if it's 0 or greater. Y equals negative x if x is less than 0, okay? Notice how I mentioned this earlier with annotating domain and range, but here this rule is very specific. This 0 needs to go, it can't be with both. Notice that x is greater than or equal to 0 for this function, so I can't have the bar here. Okay, so x is less than 0, because 0 is already accounted for. So on piecewise functions, you need to be specific about that. What do you think this function is going to look like? Okay, it's your absolute value function. Okay, so for less than 0, y equals negative x, right? Okay, if x is negative 1, what's the opposite of negative 1? 1. Okay? Okay? I plug in negative 1, what's the opposite? 1. Negative 2, what's the opposite? Negative 2, positive 2. So that's your y equals negative x line. Basically, what's your slope? Negative 1, right? Simple, okay? And then over here in red, which that 0 should go there. Okay, I've got y equals, or f of x equals x. Okay? Right? X is 1, y is 1, and I've got this line here. Okay? For the second domain. So this is x being greater than or equal to 0. And this part is x is less than 0. Okay? So that's a piecewise function. Let's do one more. Okay? I've got my function of x is going to be the square root of x if x is greater than or equal to 0. And then when x is less than 0, we're going to use the f of x equals x squared. Okay? So if we look at this graph, here it is. Here's my square root function for x being 0 or greater. Okay? And in red here, I've got y equals x squared, or f of x equals x squared for x being less than 0. Okay? So that's what basically a piecewise function is. On our work tomorrow, a lot of the work we're going to do has to do with things we've already talked about, where this is concave down, this is concave up, and what's my domain? My domain here is negative infinity up into not including 0, and my domain here is 0 or greater. Where's this function increasing? Well, it's increasing from 0 to infinity. Where's this function decreasing? From negative infinity, because where's this graph stop? On the x-highway, this thing, although it's moving very slowly, it's still getting wider and wider. So this graph goes from negative infinity to not including, up to 0, but not including 0. So domain, and what's my range? For both these functions, those are things we're going to be going over. It's obviously, my range, either one of these will give me the range. They both go from here to infinity. So my range is 0 and greater, from 0 to infinity. Okay, either the red one or the blue one will give me that. Okay. All right. So anyway, that's the range. This blue takes care of the 0 part, right? Okay? That's a piecewise function. Different functions for different parts of the domain. Okay? Pieces. Okay? And that's about it. It's a short video. We should be ready to go tomorrow. Very easy worksheet. Start off with our first 100, and I hope everybody, obviously if you're watching this, you got the notes. Okay? Have a good day.